We are going to be calculating the area between the x-axis and the curve from the function f of x equals x squared plus 1 on the interval from 1 to 3 by using a left Riemann sum with 4 equal rectangles. So the first thing that we're going to do is we're just going to separate this into 4 equal rectangles. There we go. So the next thing that we want to do is we want to figure out what the length of each rectangle is. So we're going to call that delta x. Now the way they calculate delta x, so we come over here, delta x, is we simply just use the place that we ended with, or we started with, and how many rectangles we have. So we ended at 3, we started at 1, and we have 4 rectangles. That's going to give you 1/2. So that's our delta x. So here we have 1, that means this is 1.5, so it'd be 2, we have 2.5 here, and 3. Okay. So now we're going to want to find the area of each individual rectangle. Now that we have the length, we need the height. We use a different color for each rectangle. So our first one is going to start at 1, and because we're using, again, the left Riemann sum, you want the rectangle to be connected to the function in the top left of the rectangle. So that means our rectangle is going to start right here, go across, down, like that. Now our height is going to be f of 1 because the top left corner is at the area x equals 1. So our next one is going to be at x equals 1.5. Use a different color here too. Again, the top left corner. So that height is then going to be f of 1.5. So it means this one again, we're going to start at the top left corner. It's going to be f2. And we'll pick a purple. And our final one is going to be over here. It's going to be f of 2.5. So now that we have the height, and now we have the delta x would be the length, now we can calculate the Riemann sum. We can calculate the area of each individual rectangle. So I'm going to come down here. The approximate, because that's what this is not 100% the actual area. This is only based on the 4 rectangles. Approximate area. That is going to be equal to the length. Because they all have the same length, we could just write delta x. And then because they're all going to be multiplied by the same delta x, then we could just add up each individual height. That would be f1 plus f 1.5 plus f2 plus f 2.5. Close that. Now we know our delta x we solved over here before to be 1/2. I'm just going to write 0.5 And now to find these values, all we're going to do is we're just going to plug them in to our original function. So f of 1, plugging it into the function, that gives us 2. F of 1.5 is going to give us 3.25, sorry. F of 2 is going to give us 5. And f of 2.5 is going to give us 7.25. And now with some quick math, we find that this is equal to 8.75. Now again, this is our approximate area. This is not the actual area. Now another question that they will 100% give you on the AP test is this an overestimate or is this an underestimate? So by looking at the graph, I'm just going to pick a different color. I'm going to go with this color. By looking at the graph, you can see that from 1 to 1.5, we're losing all of this area. From 1.5 to 2, we're losing all of this area. From 2 to 2.5, we're losing all of this. It's not shaded in, it's not covered by the rectangle. From 2.5 to 3, we're losing all of this. So the answer to the second part of the question, is this an over or an under approximation? Your answer is going to be an under approximation because you don't get all of this area in each interval. So this is going to be an under approximation. Now again, we did this with a left Riemann sum. You could do this with a right Riemann sum or a middle Riemann sum. The same exact process. You're just going to line it up with a different point. So instead of doing to the left of the rectangle, you're going to either align it to the middle or to the right. You're still going to calculate your delta x. You're still going to come over here and solve it, and then you're going to do the same process. You're going to have the same length, which you don't have to, but in this case we did. We did 4 equal rectangles. So you can have the same length and then just add up each individual height on each rectangle on each interval. Okay, and that is how you solve a left Riemann sum with 4 equal rectangles.